Topic 17-4, problem solving. Okay, your essential question, how can you use objects to solve problems? So if you can do this, you got this chapter down. And it is presented by Yes Me, Ms. Villaseñor. Let's do some learning. Okay, on this section, follow me on the top right of the math book under the visual learning, and you're going to see how there are two figures here, and they identify one of them as figure A and figure B. Now, let's forget about figure B for now. We're going to focus on figure A. And this is about using objects, and it gave us a measurement that this picture, figure A, represents a volume of 2 cube centimeters and an area of 10 square centimeters. Now I'm going to describe how do they come up with the volume and how do they come up with the area. Okay, pretty much volume just means it represents how many cubes were used. We used 1, 2. That is your volume. Okay, that's how we get the number 2. That's simple. Now the area part is a little bit more tricky, but we can do this. It represents how many faces, surface faces, okay? So that means on the outside being shown. So I will label the ones that we can see from the picture, right? We could see this face, 1, 2, 3, 4, 5. We could see these, right? But we have to know that there's some hidden faces as well. And behind 1 and 2, right, then we would have the face 6 and then the 7, right? And across from 5 right here, we would have 8. And then the bottoms, this would be 9, and that would be 10. So that's how we get 10. And that's how you would, how they came up with the measurement for volume and the measurement for an area using those cube objects. Okay, now for figure B, don't worry about figure A, that was from the last example. This time they're not giving us any measurements, just the picture and these measurements here. And we have to come up with what is the volume and what is the area. If you recall, the volume just means how many cubes are we using? We are using 1, 2, 3 cubes. There is your volume measurement. So the volume is 3 cube centimeters. Now area, remember the area is going to be how many surface faces are being shown. Okay, so there's some ones we could clearly see from the picture and some hidden ones that we can't see. So we'll start with the red to identify the ones that we can see. So we see 1, 2, 3, 4, 5, 6, 7. Okay? And then in black we'll identify the ones we can't see. So then we know that there's another one here, so 8. Then we have another one here, 9. And then 2 here, 10, 11. And then the bottom basis, 12, 13, and then 14 at the bottom there. Okay, so the area represents 14 square centimeters because those are the surface faces. Okay, and that is our measurement for that figure B. Figure B. Okay. Okay, the next section is they're giving us a measurement, and we have to use. We have to figure out how many cubes and how many cubes and what would that figure look like to have a volume of 4 cube centimeters and an area of 18 square centimeters. Okay, so if you recall, the volume is pretty much the number of how many cubes we're using. So we know we're going to use 4. Okay, so what if we do like 4 cubes aligned together, okay? Is it going to give us the area of 18? Well, let's find out. How do we find 18? We have to count the faces, the surface faces, right, that are shown on the outside. So we have, if we have 1, 2, 3, 4, right? That's on the front. And on the top, 5, 6, 7, 8. Then we have the side one here, 9, right? And so that means that this hidden side here would be 10. The bottom would be 4 more, right? Because then 11, 12, 13, 14. And then the back side would be 15, 16, 17, 18. Okay, so that would work. That could be one shape with the area of 18. Remember, you can, when you use objects, you could rearrange. Let's see, what if we make it where we use it like this? And this is a top view. So imagine these are 4 cubes placed like this, and that would be representing the volume. And then we're going to count the faces to see if it gives us 18. So 1, 2, 3, 4 on the top, right? And at the bottom, 4 more. So pretend this is the bottom view here. 5, 6, 7, 8. And then on the side, you're going to get 2, right? So 7, 8, 9, 10, 2 on this side, 11, 12. I'm forgetting the 2 on this side here, 13, 14, and the other 2 here, 15, 16. Oh, that wouldn't work. So if we arrange them this way, it would not give us the area of 18. It would give us the area of 16. Okay, what if we rearrange them like the way the book has it? It has 3 lined up this way, and let me try that again. Right, 3 this way, and then another cube this way. Pretend this is the top view. And then, so then that would be 1, 2, 3, 4. And then the bottom would be, this is the bottom view here, right? 5, 6, 7, 8. And then this side would show 9. This side would show 10. And this view here, 11. And then the front view here, 12. And the view behind here, 13. And then here, 14. And then the back here, 15. And then this back here, 16, 17. And that would give us 18. So this shape would also work if we line them up this way. Okay? So, in conclusion, what strategies can you use to solve this? Well, if you actually have cubes, you can manipulate and move them around. I believe Pearson has tools where you could put cubes together and play around like that, or you could use drawings like I just did. So if you need help, ask your neighbors or ask your teacher.